Hi all, this video is about Experiment 5, Chemical Equilibrium, Virtual Lab and Post-Lab. The objective of this experiment is to study the effect of concentration and temperature on chemical equilibrium, to determine the equilibrium constant Kc of a reaction. Part A. The effect of concentration in the formation of thiocyano-iron-free complex ion. First, there are 4 test tubes labeled as A, B, C, and D. The test tube D serves as a control. These 3 set of results is from test tube 1 by adding the solution with 1 ml of 0.5 molar iron nitrate. Test tube B, add 1 ml of 0.1 molar KSCN. Test tube C, add 6 to 8 drops of 2.5 molar sodium hydroxide. So now, please observe what is the difference or the changes of the intensity color after adding different solution. Initially, the color is in red solution. Now, what happened? The intensity color increase or decrease or change to other color. You can jot down the observation. There are 3 results. Test 1, Test 2, and Test 3. You have to compare the color of the observation with the test tube D, which serves as a control. Next is about the discussion. For test 1, addition of iron nitrate caused the concentration of iron 3 plus to increase or decrease. So the distance system respond by decrease or increase the added Fe3 plus. So the added actually give the hints for you all. Something that added, we will try to decrease it. So what happened to the concentration Fe3 plus when the iron nitrate is added? Okay, I think you are clever enough. Know what is the answer for this column. As a result, a net forward or reverse reaction occur, or the equilibrium shift to the left or right, and therefore the concentration of iron cyanide increase or decrease. Okay, for test 2, when SCN negative is added to the system, it reacts with iron 3 plus to form more or less of this compound. So this causes the position of the equilibrium shift to the left or right. And as a result, the red color, lighter or darker. Okay. Test 3. Addition of sodium hydroxide decrease the amount of iron 3 plus because hydroxide ion react with iron 3 plus to form a what kind of precipitate? Of iron hydroxide. Some of the iron cyanide ion dissociate to replace what ion? Okay, causing the equilibrium position shift to the left or right. So try to fill in the blanks by yourself. Part B, the effect of temperature. Let's enjoy a short video.
A solution of cobalt-2 nitrate contains hexaaquocobalt-2 ions, which are pink in color. When some hydrochloric acid is added to the solution, the equilibrium shifts to the right. When equilibrium is established, the solution becomes violet in color. An equilibrium exists between the pink hexaaquocobalt-2 ions and the blue tetrachlorocobalt-2 ions. When warmed by the water bath, the solution becomes blue, so the equilibrium is shifted to the right. When cooled by the ice bath, the solution becomes pink, so the equilibrium is shifted to the left. Why does the temperature affect the equilibrium of this reaction? To answer this question, we must learn something about the energetics of the reaction.
Is that at room temperature, the solution is in purple color, and then there is no change in the color of the purple solution. What happened when the purple solution put into a ice bath? And what happened? The test tube solution put inside the hot water bath. So you have to jot down the result, meaning that the initial color for test tube 2 is purple color, change to what color? Same for test tube 3, purple color, change to what color? Okay, then you have to take out the test tube 2 and 3 at room temperature after you finish the part 1. So part 2, you have to take out test tube 2 and test tube 3 put at room temperature and observe again what is the changes for them.
Changing the temperature of a system at equilibrium changes the energy content of both reactants and products relative to each other. Both forward and backward rates will change, but not in the same way.
In exothermic reactions, heat is also a product. Adding heat to the system will shift the equilibrium to the left, so more reactants are formed. If the forward reaction is endothermic, heat is a reactant. So increasing the temperature shifts the equilibrium to the right. More products are formed. A change in temperature changes the value of the equilibrium constant. For an exothermic reaction, the concentration of the products in an equilibrium mixture decreases as the temperature increases. So the value of the equilibrium constant will decrease. The opposite will be true for endothermic reactions. Now, let us come back to the reaction we were discussing before. The temperature dependence of this reaction indicates that the forward reaction is endothermic, while the backward reaction is exothermic.
After watching for the video too, okay, now you can try to do the discussion by fill in the blank. So this time got bonus. Why? Because the choices are given. Okay, so please fill in the blank carefully. Part C. Determination of the equilibrium constant.
Now part C. For the 0.5 molar antimony chloride in 6 molar HCl into a beaker. Pipette 5 ml of the antimony chloride in HCl into a 100 ml conical flask. Set up the apparatus as for titration and record the initial reading of distilled water in the burette. Carefully add distilled water from the burette into the conical flask while swirling until a faint white precipitate is obtained. This is what we want, the faint white precipitate. Record the final reading and the volume of distilled water added to the conical flask. Calculate the value of the equilibrium constant, Kc.
Since you cannot conduct this experiment, so Madam Kong will give you the result. So for the volume of water that we use is 15 ml. So you can apply this final volume to help you proceed with the calculation part. Next is the calculation part for part C. First of all, I need to find the number of mole of SbCl3 by applying the formula N equal to mV per thousand. Please do remember the M is 0.5, V is 5 ml, so have to divide it by 1000, so become 0.005 liter. So this is the number of mole of M. And then the volume, initially we take 5 ml of the solution, and then after the titration, it is now become 15 ml, total 20 ml. And remember, change to liter, so this is the X volume. Okay, that's why the new concentration of the SpCl3 is mole over volume. So m mole divided by x liter. So you get the concentration A. Next, for the number of mole of HCl, okay, it's the same, 5 mil and then 6 molar. So applying N equal to mv per thousand, so you get the N mole. And then the volumes is here, x liter. So now you get the new concentration for hydrochloric acid, B molar. Okay, just how we already mentioned, the Kc expression is the concentration of product over concentration of reactant, and then don't forget to the power of its coefficient. So concentration HCl2 is concentration B, so B squared over A. So you get the new Kc value. And then the Kc value is no unit. Next is exercise. Please answer these two questions and then make a conclusion towards this experiment. There are two. The first conclusion, what are the effect or factors that affect the chemical equilibrium? And the second one is, what is the Kc value for this reaction? The reference, you just jot down any website, reference book that you have used. Okay, that's all for this video. Please do remember, subscribe, like, and share. If you have any question, please don't hesitate to consult with your practical lecturer. Stay at home, stay safe. Thank you.